Okay, here we go again. Okay, so welcome back. So where we finish off, right? We look about the deformation pattern, and I hope you guys are clear. If not, it just takes time. Okay, you visualize this, right? So we have formed the other equation, right? So we have formed moment as function of x. So this will be equal to omega over 2, right? And then we have minus x squared plus by lx minus by al plus by a squared and then minus pa. Okay, we already have that function. So now we're going to look at point C. Okay, now we're going to look at point C. So point C is going to be chaos. Okay, point C is going to be chaos. So I'm going to...
Eugene, you're just
Yes.
showing your webcam.
Am I?
Yeah.
Can you all see my... Oh, I do apologize.
I can see it over here.
I can see it too.
I
I see
can
it.
Yeah,
I had to click it.
you're good, Eugene. You're good.
Okay,
Keep going.
okay. Colin, you have to... Are you okay, Colin, or no?
Yeah, I'm fine. I just had it clicked onto your webcam and it made your webcam full screen.
Okay, so it's you cheeky sort. Okay. Right. So I teach you how to check and we are good. So now we are going to look at point C now. Okay, we're going to look at point C now. So point C is where x is equal to L minus A now. Okay, L minus A. So we are going to look at, if we're going to do from point C is at x equal to L minus x. So now we have this now. Okay, so you have point A, which is your P. You have point B, which we have what? I'm trying to, after the break, I just forget my loads. P plus by omega over 2, L minus by 2A. And then we have a load over here, right? So now this load over here will be equal to L omega L minus 2A, right? And then we have V at point A, V at point C, positive shear, positive bending moment assumption. Okay. And our datum did not change. So now we are very sure that we are very specific about our distance. So from here to here, especially at this point, we know that this is L minus A. Okay. And the distance from here to here is A. So the distance from here to here is L minus 2A. And then from here to here is bracket L minus 2A divided by 2. Okay. So there's a lot of stuff involved over here. So when we do this, okay, we are going to carry out the analysis from left to right. So the number of terms that you have to consider P plus omega 2A, omega bracket L minus 2A. And then you have to get all your distance right. Okay. And the possibility to get it wrong is very high. So what I'm going to do now to you is we're going to analyze from right to left. Okay, so I'm going to show you. So from left to right, these are the things that you should have. Okay, I'm not going to show you now. If we do our analysis, okay, we're going to do our analysis from right to left. So we are going from right to left now, okay? So geometric distance is still the same, right? So we are still wanting to do x equal to L minus A, still the same. So from here to here, right? This is our L minus A, right? And then this will be our point C. And this will be our point D. And we know that we have a force down here. We only have one force down here, which is known as P. Right? And then at point C, we have another force down here. This will be equal to P plus by omega over 2 L minus 2A. Right? And then we will have positive shear V at point C and positive moment M at point C. And the distance from here to here, we know that this distance is equal to what? It's equal to A. Right?
Eugene, isn't that negative moment?
Hey?
Isn't that negative moment?
The moment at C?
Yeah.
That is the notation that we assume positive shear, positive bending moment if we do analysis from right to left.
Okay.
Does that make sense? Look at where we started. Okay, where we started, right? I deliberately make you learn this, right? Assumption based on positive shear, positive bending moment. If you go from right to left now, this is the assumed positive bending moment, positive shear. Can you see that?
Yeah, I was thinking a positive moment was always counterclockwise.
No, not that way. Okay, you don't do it that way. Okay. Wait, there's something that's not right here. I'm correcting it. Oi! There's something wrong with my pen. Oh no, it's the user. So this is your analysis direction. Okay. All right. So now, can you see the strength of analyzing from right to left now? Yes or no? So how many terms we have? We have 1 and we have what? 2. And then when you take moment, you only have one force to take your moment from. Not how many? Not two forces. Not if you take moment, you have 1, 2, 3. Down here, you take moment, you only have what? You only have your P. Over here, P plus by omega over 2 bracket L minus 2A. You don't need to consider. It's because it has no distance. Right? Okay. So now we are going to do summation about forces in the y direction. Will be equal to 0. Okay, so will be equal to P minus P plus by V, sorry, minus P plus by P plus by omega over 2 L minus 2A, okay, plus by V at point C. The whole thing is equal to 0. Okay, so V at point C is equal to minus omega over 2 L minus 2A. Okay, so that is our what? That is our shear force at point C. Then we're going to take our moment, summation about moment, right? In the Z direction, where X is equal to L minus A, the whole thing will be equal to 0. So we're going to take our moment down here now. Okay, we're going to take a moment down here. So the distance now, so where the pink dot is, we're going to take a moment. So it's going to be counterclockwise. So minus PA, right? Minus PA, then minus M at point C is equal to 0. So M at point C is equal to PA, minus PA. Okay. So from here, now this is so much easier, yes or no? If you want to go the other side, okay, if you want to go from left to right, go and have fun, okay? I don't waste time, okay? The answer will be the what? Will be the same, okay? I'm not going to waste your time to derive everything, will be the same, okay? Maybe I'll do it later, right? So once we go back here, right? So once we go back here now, our table. So at L minus A, so V at point C is equal to minus omega over 2 L minus 2A, right? So we draw this now. Okay, so we will draw from here to here. Right, so this will be equal to minus omega over 2 L minus 2A. Okay, so that is our point. And then our moment at point C is equal to minus PA. Okay, so at this point, like what we say is already minus, we already calculated in the other equation already, right? We already, when we are testing this equation over there, we already calculated. That's why we have the value minus P over A down here. Okay, right. Then likewise, okay, so we have point C. Then the next one, I'm still going to go from right to left. Now you see the convenience of right to left now, yes or no? Right? If I were to do this direction, I have so many points to consider. That's why I want you to learn from left to right and right to left. Okay, I want you to be very familiar with it. And it's not difficult at all. Okay, it's not difficult at all. So now we are going to do from between point C to point D. So you have L minus A x to L. Okay, so I'm going to do my analysis from right to left again. Okay, so we are still going to draw our datum, still left hand side. Okay, so this is our point. Okay, so now over here, this becomes your x. Okay, that is your x. So the distance from here to here will become L minus x. This is point D, right? You avoid point C so you don't have the reaction force. So you have P down here, and then over here, this is V as a function of x, and M as a function of x. Okay, so from here, you again static analysis, summation of forces y is equal to 0. So you have minus P, right? Minus P plus by V as a function of x is equal to 0. So V as a function of x is equal to P. Okay. So from here, the shear force will be positive from L to A. Okay. Then we take moment. Summation of moment in the z direction along the variable x. So we are taking our moment at the dot I'm drawing now. Okay. At the pink dot I'm drawing now. So this will be equal to is going in a clockwise direction. So minus P L minus x, and then M as a function of x is also going clockwise, minus M as a function of x is equal to 0. So you have M as a function of x is equal to minus p, sorry, would be, yeah, minus p L minus x. So this is equal to